So the history of PPFMs, which stand for pigmented facultative methylotrophs, that's a mouthful, comes out of research out of Maryland. Dr. Mark Holland. We don't have his name anywhere on there, do we?
Oh yeah, it's okay. Right under the photo.
I see it. Footnotes. Thank you. Yeah, this research goes back several years. The PPFMs have been known in the scientific realm for years. We didn't know what they did or why they were on the plant, but it was commonly known that you could find these on almost every plant out there. Dr. Holland started doing research on that, but one of the bigger constraints taking this commercially is just the fact that it's very hard to make these bacteria, but they are very common in the symbiotic relationship in the soil for the plants to take up nutrients and respond to abiotic stress. Switching gears, for those of you who are new to Newfields Ag, this is our team at New Leaf. Obviously, this isn't everyone, but this will be a lot of the people that you would interact with. So we have Elizabeth Carlson, who's our customer operation manager. Derek is our data scientist who does a lot of our spatial information on our field trials. David Flax, our VP of business development. Mark, who's on the call here, is the director of products. So he's dealing with day-to-day interaction with our products and right now with our distributors as well. You see Allison's picture here, who's our technical product director. Oh, that's not for all the time. And then Aaron, of course, is our chief commercial officer. So he's in charge of everything that deals with everything that we sell. Vanessa is on our team for field trial operations, and she coordinates our field trial operations within the office. And our new addition is our new chief technology office, is Sean Simone. Good gracious, he was in biological products when Moses was a baby. So he has quite a bit of experience. I've worked with Sean for several years at Novozymes, and he's a good addition to the team. Going back to 9 years of technology development, New Leaf Symbiotics is 10 years old as of January. We've been working on these products for a decade now. We probably need to put 10 years of technology development instead of 9. But we've been looking at ways to apply these PPFMs in the field. We see a great response when they're applied, but a commercial product that's still a little bit of a challenge. So we've done years and years of small plot research. We've done larger field trials with growers and with companies like Intent to look at our product in real world conditions. But again, we've changed our mode of action. Our application method has changed. We've done overseed treatment. We've done corn in furrow. And eventually, thanks to Newfields Ag, we came to the planter box application, which has been a really game changer for us going commercial. Right now, we are making the claims of 9 months of warehouse temperature stability. So we covered at least the current season and 2+ years at 40 degrees refrigeration. So we can store this as we produce it and have it ready. But we're always on the move to extend that shelf life issue and time on seed to have a more viable product out in the field. All right. For everybody new who's not seen this, this is the technology that we're looking at. This is a slide showing basically the dark green is where our yields sit today, and everything above that in the olive and light green colors are the genetic potential for these crops. So right now, I think the world record for corn is around 800 bushels to the acre, but most of our farmers don't hit much over 300, even in some of the better fields in Champaign, Illinois. So that difference between that 800 and that 300 is what that light green is representing of. Every time we have drought stress or flooding or nutrient availability issues, or the weather doesn't hit right, or we have plant insects or disease, all of that takes off a little bit of that yield. And so what we're trying to take care of is the abiotic stress that's out there in every field and lessen its impact on our yield. And so we're raising yield by just taking away those limiting factors that are taking away energy and vitality away from the plant. So again, back to the PPFMs. These are naturally occurring bacteria in the soil that the plants use to interact with the soil rhizosphere and even with the atmosphere and the phyllosphere of interacting to get soil nutrients to react to stress Basically, it can turn on gene expression within the plant to adapt quickly to changing conditions. Most of our planting conditions are not ideal every year. Farmers are having to go in earlier and then go later into the planting year to cover more acres to make a profit. And so we're running into conditions that aren't ideal for these plants. So putting on the PPFMs, they colonize the plant. They allow that plant to take uptake. They'll put on a larger root system. They put on, a very vigorous plant early on, which is similar to some other bacterial products out in the field. But the difference is that rhizobia on soybeans, nitrogen fixators, essential for soybean production. But that rhizobia nodule on that plant takes carbohydrates from the plant. So it's a net draw, but it's replacing nitrogen. But eventually the plant stops that nitrogen production because the draw from the plant's too much. Whereas PPFMs are using a byproduct. They're using methanol, which comes byproduct of cell division in the plant. So it doesn't cost the plant anything to be colonized with the PPFMs. All the work that's going on in that plant is all for the benefit of the plant and no reduction in growth because of wear on the plant. Again, this is another illustration of how the PPFM works. We apply it somehow to the seed, whether as a seed treatment in furrow or preferred planter box. They start growing and colonizing. As the roots grow, the bacteria are able to grow along with it. So the colonization is always on the entire root system as it grows out. This allows, again, as the plants reach out and touch more of the rhizosphere, we have more uptake in the plant, which again increases vigor, increases yield potential, and we see a nice little bump at the end of the year because of this. But there are several modes of action in here. Nutrient uptake is the primary one we'll discuss. But it's a season-long thing. It's from the time the plant germinates until harvest, we're getting input from these PPFMs. Now, Terrasym Plus Dust is our product that is mixed with our Terrasym products, 401 and 450. Both of those are applied to the dust product from Newfields Ag. Obviously, you're probably aware of what dust is. I don't need to cover that, but it's an ideal carrier for our biology. The moisture consistency, all of that is very conducive to our product. It's a very easy blend for us. It goes out well. It's a low application volume, and we can be pre-mixed in the bag, whereas we were mixed with talc and graphite. Again, competitive products either had to keep those separate or they put them in with the talc graphite, which is very harsh for the bacteria, and typically we see low counts or even death from mixing of talc graphite with our products. So the dust product is ideal. You can apply it once, go over the top of the Pro box or in the hopper, and get this product applied. And ideally, compared to even talc graphite, there's a charge with the dust that sticks us on the seed. So it's a very ideal coverage. And what we found out over time was initially we were looking at a liquid seed treatment because that's what we've done for 30, 40 plus years is we take the corn, soybean seed, cotton seed, we run it through a liquid seed treater and apply our fungicide, insecticides, and whatever the products we want to put on there. And so we'd reached a particular rate and we wanted to shift to planter box, but we wanted to make sure that our rates, we didn't have to increase the rate because we thought, ideally, I thought the product would fall down through the planter and would not cover the seed. You'd have a hard time delivering this product. But because of that charge in the dust, what we found was putting out equivalent rates to a liquid seed treatment is we get a 10x increase in our PPFMs on the seed. So liquid, you're trying to mix it, put it on there, and hopefully it dries to the seed. Whereas with the dust product, even with a small amount of movement of putting it on at the hopper box and driving into the field, we get great coverage, and it's consistent coverage, and it sticks to the seed. So we're getting even better than we do with the traditional seed treatments, and we don't have any special equipment needed. The farmer can do it himself. The next question I probably had in the job interview probably almost cost me the job, right, Allison? I'm sure rolling my eyes.
No, we were all skeptical. We're like, really, is the powder gonna mix? But it can't possibly be even across the field. So you were not alone in your skepticism.
Well, we've done powder applied products over the years, and you watch it just go right down the system at the bottom of the planter. So I believe Aaron was involved with this. We went out to one of our large acre trials, and we had seed loaded into the planter, and at 20% across that field, we picked the planter up, collected seed directly from the planter, put them in a test tube, sealed it. We drove into 50% of plants in that field, collected again, and then again at 80%. Took those seeds back to the office, and we did recovery for the PPFMs off of that seed to see how consistent was the coverage across the field. Did it stay on the top? Did it work its way down to the bottom? Did we have a lot of leftovers? And as you see on the 20, 50, and 80% numbers under those little test tubes, they're basically equivalent. Those would not be statistically significant differences. Those are equivalent numbers. So that one application before we started planting covered all of the seed and covered it consistently. And sometimes there's a small amount of powder left at the bottom. We probably put our rate a little bit. We want to make sure there's a small amount left over, but as you see, it's consistent coverage and it sticks to the seed. And this is the one that I found hard to believe, but it's one of the selling points we've come across is it's going to be on there and consistent across the field.
And that was 20 fields each for corn and soybean.
Yeah. I mean, I'm a sole believer. That's why I like this product is the application is just spot on. And so the farmer knows specifically I'm putting out this rate of PPFMs across the field and it's consistent and on it. It's easy. Liquid seed treatment, you got to go pay someone to do that and they have to charge you. And to be honest, most of our distributors, the big guys, the Nutrients, the Helenas, that's where they make their money is off treating liquid seed treatment on the seeds. It's not off the fungicide, insecticide. It's that right there. So there's a lot of money tied up in that application that suddenly we don't make not necessary for our product. So let's skip on to the next slide set here. Is our trial results. We can apply it. It looks great, sure. But what does that mean to the farmer? And so our average over our last several years, I believe we updated back in January and February. So this is as of the 2022 season back, is a 70% win rate on soy, 67% for corn, which is very high for a biological. 60% is kind of the goal you reach for. Most products don't get much above 50. So to have a biological at this high win rate is exceptional. And it's something that speaks to the farmer. What are my chances of, yes, I see your 3.5 and 6.9 bushel response, but how frequently do I get that result? And so our 70 and 67% win rates are a big selling point. The root area we've been able to measure, I still think these numbers are probably low. I'd like to revisit these, but that's still a positive. We're saying, here's our mode of action is that we're increasing that root area. So that's access to nutrients, access to water, access to everything else in the soil. We can explain that with our measurements on the roots, and we see it, and especially the nodal root lengths in corn. We're really turning that plant on to putting in roots and putting them deep. But what's surprising to me is we do increase the uptake of NP and K, and part of that is just root area. So we're touching more soils, we're touching more of those nutrients. But we tend to drive some of these nutrients into the plant at higher rates, specifically iron and manganese, because of a molecule these bacteria produce called siderophores.
You've got a question from Jared.
Oh, sorry.
Go ahead, Jared.
Yeah, jump in there.
Okay, we'll see if my microphone is working. Is this okay, good deal. Had a situation this spring where a grower had already planted his beans, and I'm looking at the iron and the manganese concentrations and such here. The beans are already planted and up, and he was seeing iron deficiency chlorosis. Is there an application option at once the beans are up?
Yeah, I correct me when I jump into where I don't need to put my foot in my mouth, Allison. But I mean, the only application that I could think of at that point would be a foliar application, which is possible. We've not done a lot of work on it. It's not on the label. These PPFMs will colonize from a foliar application, probably go down to the roots. It would take you longer. Not sure about the rate. It might be something we look into, but at this point in time, we don't have data that suggests here's how you apply that foliar. I think it technically could be possible. It's just not something that we've addressed at this point.
It's just not labeled at the moment, which kind of stops us.
Yeah, and we really just haven't looked in depth at foliar applications. I mean, we want to be on the plant. Let's say the plant. So that means the seed is the earliest we could apply. We start colonization. The results from that colonization interaction with the plant, we want as soon as possible. That might be something that we want to consider eventually in those iron deficiency fields is if you don't put our product out, should we come back and help you? One I hadn't thought about before. Yeah, we may need to have that discussion further, and maybe at a different time we readdress that.
It was prevalent for me because of drought symptoms this year, but the question that comes to my mind is, did I see it more because of the drought this year, and it's just always there, but flying below the radar. So
from what I've seen, the drought really seems to show that out. And again, you're already dealing with enough stress in that plant, and the moisture is just adding to it. And the iron uptake is probably affected because it's in solution in the rhizosphere. So if you don't have water, that iron's probably not moving much at all. But again, that's a concept I hadn't thought about. But yeah, let me think a little more about that before I, again, stick my foot in my mouth and have to dig it back out. But again, the iron and the manganese here, we increase that number. Typically, when you take fertility studies, and I've done this for years for my other jobs, if you lower or increase the rate of fertility on micronutrients or the macronutrients, you don't see the difference in the leaf tissue concentrations. It's more the plant size. So if you're limited in nitrogen, the plant's going to be shorter, but it might have the same percent nitrogen as the plant next to it that's not deficient. So the fact that we are able to increase the iron and manganese means we're actually pushing this into the plant. And we're doing this as an uptake. We're also taking that percentage of that ppm or multiplying it by the biomass of the plant to actually get more grams uptake into the plant. And so we know we're driving this into the plant, but iron and manganese for the legumes, iron is essential for leg hemoglobin, for the nodules and the infixation. Manganese and iron are both essential to chlorophyll production. So that's carbohydrate production for either a legume or for corn. So these are essential micronutrients, and we know that we're pushing them in the plant. And this is probably one of our bigger mode of actions that we're going to talk about is we are not limited in these micronutrients that you don't always notice, but it's costing you yield out in the field, and we're going to solve some of that problem. Ideally, in the iron chlorosis field, I think we should look great. These numbers are not from iron chlorosis fields. These numbers are from our 10 and 20 locations, large acre trials that we looked at that are in the middle of the Corn Belt. Probably, I would say 6.5 pH would be the range they were shooting for. These were not high pH iron deficient soils. So even in those conditions, we're driving iron and manganese into the plant. I think we'd probably see a better, even higher result in iron deficiency soils, but we've got to do some more work in that as well. We have a slide. I think we've taken it out, but Bex.
No, it's in here.
Okay, yeah, we've been in Bex PFR's iron chlorosis trials for 2 or 3 years now.
Yeah, I think it's coming up. So.
Okay.
Yeah.
Maybe not.
It is. It's the next one after this one.
Oh, I see it. Okay. All right. Thank you. They're right there at the bottom. Yeah, this is the phenotype we see in the field. Before I get to the iron question again, typically, it's the big roots. I almost hate the fact that, it's big root product. Big roots are the phenotype that you're going to see in consistency across the field. You dig them up and look, you're going, oh yeah, those are bigger roots. But these bigger roots are just part of the story, the mode of action of bacteria. Bacteria have the ability to change their response and their interaction with the plant based on the environment. Big roots are one of those things that rarely have I come up with a farmer and he complains saying, doggone it, you put big roots on my plants. I'm unhappy. So big roots, again, are what you want to have, they may not be a limiting factor toward the end of the year, but I'd rather have them than not have them. So this is the phenotype. If you go to dig out plants, early season especially, you go out there and look at those, you'll see the root area, the roots are increased, especially those small secondary feeder roots that are coming off those main roots, the tap roots and the large feeder roots. It's the secondary, and they're small, hard to see, and you don't see them on these pictures, but that's really where we are increasing the numbers. Now, back to the iron chlorosis story. Bex has run theirs. We have several years worth of data. What we don't have from Bex is multiple locations. So to be Bex PFR proven, it's got to be at least on 3 locations or more for 3 years. They only have the one site typically each year looking at iron chlorosis. So our return on investment, our response is great. You see the numbers here, a 7% increase in foliar iron, a 19.4 in the intent trials. We're helping with iron chlorosis. We need more work on it, but we can't get the Beck's PFR until they include more sites. But this is Beck's numbers that we're looking at. It's not ours, it's third party, independent. So we're quite happy with the product out there on those fields, but it probably needs something we need to put more time and money into to increase those sales in soy. Now jumping to corn, again, it's those large roots, especially there on that left picture. Yeah, when you start digging these up, you start seeing typically they're larger. They often have a golden shine to them, especially when they include the TS201 product. They look different than the plants that aren't treated. So if you have someone that's questioning, if you can get them take it to the field and they've got a treated and untreated part of the field that are near each other, dig them up and look at the roots, and you'll see what we're talking about. This phenotype is very consistent. Even when the yields are not always there, let's say it's a perfect year for moisture, fertility, and temperature, we're putting on the big roots, and it's easy to go out and find that. Now, our wonderful packaging with the Terrasym Plus Dust, or is it Dust Plus Terrasym? I always get confused with whoever I'm talking to. But these are our current packaging for the next year. This is what the farmer will open. For the soybeans, they're going to treat a 40-unit pro box. The corn's 50. There are scoops inside that can treat individual hopper boxes. But that's a lot of corn and soybean to treat with a small package. This is a low application volume. The application of the dust, is much lower than talc and graphite. So that's a little bit of a education thing that we try to push to everybody. And I know I've heard it from both Michael and Brian for years of, we say it's half scoop, it's a half scoop. But again, it's a small volume, easy to apply for the farmer. The videos that are out there, the demonstration we had at the Pro Fields meeting earlier this year, it's simplicity defined. I mean, you couldn't make it easier to apply this product. And like I said, it's now with obviously a corn plant and a soybean plant, maybe we won't have those calls. If I put the wrong product on, what's going to happen? Those are always probably you're going to be impressed, but yeah, you probably would have been better off with the other one. So these were our new packaging, and again, they look great. You're not quite ready yet, are you? Some of these trials for the bioprotection are maybe out, but we are going to talk in a few minutes. I'll hand this over to Allison about our TS201 product. This is our EPA registered insecticide. I was thinking wrong backwards. But what we see now, this is just TS201 alone has been what we've tested until this year. We were looking at it as a standalone liquid seed treatment. So this product has been tested just as the TS201 alone. A lot of our data is going to show that. What we're going to be selling in the field will be a mixture of the TS201 plus the Terrasym 450. I'm even happier with that, but we do have this product out there, and it's been impressive. And for what I've seen this year, driving around and looking at roots, I'm very impressed.
Roger, you've got another question from Jared.
Look up and look down. Jared, just jump in. You don't have to raise your hand.
Just jump in. Yeah.
Well, in fairness, I got a peanut gallery behind me, so taking over my microphone. Okay.
I've done that a few times,
I should know this question. I apologize, everyone, that I don't. What's the seed life of Terrasym once the bag is opened? And is it the same for 201?
Yeah. Allison, you want to jump on that one? You've seen the latest numbers from Whittick, right?
Or maybe Mark? On seed life or the life of the bag if you're opening and closing it?
Both ways, if you don't mind.
Yeah, so on seed, and it keeps increasing. That's why I have trouble keeping up with it. I'm like, wait, what year is it, right? So our formulations team is doing all this testing and to really assure how well we're doing on the seed and how long it can stay on the seed. Aaron, correct me if I'm wrong, but I think it's like 4 months at this point that you could pre-treat a pro box with Terrasym Plus Dust, and you have 4 months before you start seeing any decline in cell like the living microbes.
Yeah, we're still above the threshold easily. I mean, I know some of the guys with the inoculants, they treat in February, but even that early seed treatment then is still going to be fine for us going on with this product. And what's the latest for the shelf life? Because I know we're trying to get to a 2-year product, but we're not there yet.
And again, correct me if I'm wrong, but shelf life is the 9 months. And we don't love if you open and close it all the time, right? Like humidity is a killer. So if it's somewhere dry and you're opening and closing it, that's okay. It's not the best.
And refrigeration helps, but you know, at least contamination doesn't seem to be as big an issue with like the inoculants. Once you open those, you had about 24 hours before the gunk started showing up inside that liquid. So yeah, more of a humidity issue. Once these PPFMs become wet, it's our issue with our liquid seed treatments. The viability is not as long once it's wet, so we try to keep it dry. That's why the planter box is such a good method for our particular product. It fits directly in how we want to apply. It gives us longer time to get mixed and on the seed and then stay alive. So right now the 120 days on seed and then the 9 months of the product. The cooler you can keep it, the better, but that still gives us one season. We're just not, it's going to be hard to go to 2 season or even a late season fall planted weed at this point in time, but we're pushing that to go further.
Exactly. We're working on it. That's the goal, is for future products to be like, oh, you can use it this year or use it next year. We're just not quite there yet.
This is Mark Heinrich. I just want to chime in. The on-seed stability is 6 months. So
is it 6? That's why I can't keep it in my head, because it's so amazing. Thank you, Mark.
Yep. So you can add it to the seed, do the seed treatment, and then 6 months later it's still good. And we're still going, so we're in good shape.
Yeah.
Thanks,
Our
Mark.
formulations team is amazing, and they're like, oh, we tweaked this, and now, okay, so it's 6. All right, I got to write that on the wall. Thank you, Mark.
And again, guys, part of that difference is if it's longer if it's applied dry, like this is a planter box. If it goes through a downstream aqueous seed treatment, over treatment of soybean, it's more like 3.
Thanks.
Thanks, guys.
I have a question while we're on questions. We talked about the antagonism of talc graphite, and I have educated a fair amount of folks out there. And they've called me on it a couple of times. So do we have something to back that up from a research piece or something that I can pull, I can share with them, like, here is here is the third-party research or whatever it looks like. That would be extremely helpful, because I think it's an extremely big deal and a great story for us, right? So if you guys can find or locate or lead me to.
I don't know that there's any third party on that. We can look. For us, that's more internal product development data, right? And because we're also in a product with talc graphite in a co-pack, we have to be careful how we talk about talc graphite as
but
well.
It's known in the industry. It's not just us saying this. When I worked at Novozymes, my first question on a complaint call with soybeans was, oh, did you use talc graphite? And they go, yeah, of course I did. And I'm like, thanks, have a nice day. It was good talking to you. And I get in the truck and leave. We absolutely said, do not apply this. Even 7 days, we said, do not apply these products with talc graphite. That was our recommendation. So it's known across the industry. I'm not sure how well it would go if we took all these products that are out there that are pre-blended with talc graphite and we did a CFU recovery count. Might raise a stink, but that would be interesting if we could convince somebody with a university to do that. But I don't know if there's any scientific paper.
Yes. So I know you guys are in an interesting position there to carefully what you can share and what you can't. So give that some thought anyway.
And that's why we always say, dust is so biologically friendly, and that's what enables us to do the blend, with the super convenient packaging. It's just all together there in the pouch. It's blended, it's stable, right?
Yeah, and there's some that do it, but they must be raising their moisture content of the talc to match the bacteria. And then I wonder how useful the talc is. So it may be possible to keep them alive, but not with keeping the talc at a low moisture percentage. So yeah, there are a bunch of them out there. But again, with most biologicals, if I'm making a 2 to 3, 4 bushel claim on soybeans or even corn, that's hard to see at the end of the year that, oh yeah, I bet that killed. They're not thinking about that. They're going to blame it on the weather, the hybrid, the fertilizer applicator. It's hard for someone to say, oh, that's actually living bacteria. When I worked with inoculants, we would get our competitors' product in, and probably 3 out of 4 out of 5 times, there'd be nothing alive in the bag or the bottle, just simply because they didn't have good quality supply. And it was impossible for the farmer to come back and check them, because I don't think even the private labs even do bacteria counts on some of these products. So you're just taking our word on the count on the side of the box. Hard to prove, and they get away with it. So,
hey Dan, so I heard a couple of things. So one, you were asking about third-party testing, and that's hard for us to get because PPFMs are not an easy organism to culture and to count correctly. We're actually spent a lot of time and effort and scientific brain power figuring out how to do that nicely. So that's not something that you can just kind of offload to a third party testing facility very easily. So the third party is kind of tough. I think your question around, do we have data that we can share? We can't put it against talc graphite for obvious reasons, but we certainly can share, I think. Let me think about how we can share the data with dust and just say, hey, this is the product stability rather than this is the product stability versus something else. So, so let me think about that, Dan, and get back to you on what we might be able to share there.
Thank you. Appreciate it.
All right. Yeah, this one is APHIS past trialing constraints. This is concerning our TS201 product. And I know Newfields Ag is aware of this, but for the last 7 years, we've been working on TS201. We've been under APHIS constraints, which means we're limited to 10 acres across the US for any application of this product. So that means small plot trials, 10 foot by 30, 10 foot by 40 plots, hard to get accurate results. And these, God bless my researchers, they don't like limiting factors other than my product. So they tend to over apply the fertility, over apply this. They rotate well. They don't have insect pests. So small plot data doesn't always directly relate to large fields with farmers applying this. So our data is coming from there, so that's the context. We are pushing out this year with Newfields Ag and our own internal trials of getting large acreage out there and as much data as we can get back in to correlate with this data, but that's been our constraint. So when you look at our data, just know that this is where this comes from. This is what it is, but this is what it's not. So,
and if we could have done large plot testing over the past, like at least 4 years, right, we would have, right? Because this was ready to nominate into large plot testing. We were just working under a regulatory constraint.
Yeah. Why couldn't they have the government shut down then, right? You know, stop me if you can. These are, well, this is, do you want to jump in at this point or
sure
hit motivation? All right. You know more about this, so take over.
So again, for our history of that small plot testing, we have been working with this organism since, I'm sorry, that's small for me over here, 20, I think let's say in 2016. So we have pretty good consistency year over year. And again, as Roger mentioned, this is just with the TS201 by itself. And we're not launching it as a standalone. We're launching it with our biostimulant, Terrasym 450, and with the advice to the grower that you're going to want this as a companion product, right? If you're using insecticide, use this also. If you're using a trait, use this also and see what you can get from both of them together. So we're not positioning it as a standalone, but we had been testing it as a standalone just to understand what it does over the past however many years. So pretty good consistency year over year, and seeing a response even under moderate pressure and even in some cases high pressure. So again, we do great on untreated, but we can move the dial on top of a corn rootworm trait as well, which is fantastic. So you can say, hey, you know, you're starting with this base technology, but we can actually make that perform better and move the dial in a positive way. And then, all right. So
this is not fair, me seeing the slides, is it? So I'm probably,
I know. So with the nodal injury scale, sometimes we see a reduction, but not always. And I'll talk about that in a little bit here in terms of our mode of action. Just like with our biostimulants, our biocontrol products have multiple modes of action. So there are lots of different things going on that get to the change at the end of the season. Oh yeah, Jared's got another question. Go for it, Jared.
I just wanted to ask, I understand using it as a companion product, is that to protect the integrity or the life of the technology against resistance issues?
We absolutely can help protect the integrity of insecticides and traits, and even, you know, maybe extend the life of those technologies. So that is one way that we're positioning it. For us, we're less worried about the insects developing resistance. We just feel that, performance-wise, as a biological, it is moving the dial, but probably not enough for a grower to be comfortable
Expectations might be
completely on its
higher.
own.
They may be expecting the level of a chemical control, and sometimes we're equivalent to the chemical control, but
not always.
Until we get this out there and the farmers get familiar with using what it does, how it works, again, you're setting yourself up for unrealistic expectations, and that's another way of saying in legal terms lawsuit. So right now we're going to be testing this until we can prove that it does work standalone. Until then, we're going to do it as a companion, but as a selling point, as Allison said, it's going to protect the IPM integrity of all these other products because it's a different mode of action that the plants have evolved with over thousands of years. That's going to be harder for an insect to overcome, and we protect whatever we're paired with. It's a great IPM tool. It's a great way of selling it to farmers who consistently use the same trait or insecticide year after year after year.
Yeah, I'd add there, Jared, and Allison's about to go into the mode of action here, but this product is not directly insecticidal. It works through indirect methods. Allison's going to point that out. So I think that's a lot of why this first year we don't want to go out and encourage anybody to displace their current practices. We think this is going to make current practices that are facing different resistance pressures to have another mode of action to be more consistent. So that's kind of how we're positioned at the first year.
Yeah, thanks, Aaron. And again, we see a bump in that low pressure, so 0.25 to 1 on the nodal injury scale. Our best performance over all of our small plot data has been at that moderate pressure, and we still can move the dial at the super high pressure. But like Roger mentioned, some of the fields he and I think Dan were in this season, like if you bump the corn with your elbow, like it falls over, right? I mean, it's the 2 to 3 on the nodal injury scale is just smoking. There's just hardly any roots left at that point, right?
Ready for the next one?
Oh, sorry.
Oh, I was asking if you're ready for the next slide.
Oh yeah. Oh, I can move it from here. You somehow set it up so I have advancement.
I'm a genius and didn't know it.
I know. Thank you. And again, as I mentioned, right, we do see a significant drop in the nodal injury score. However, we also see these changes in other things that are all working together to enhance yield, and lodging is one of them, a really big one. So as Roger mentioned, with that history of kind of our trialing, we did a bunch of small plot trialing. We tried in 2020 to do a couple of quarter-acre larger strip trials on real growers' farms. And it was difficult. We only had 3 locations that had pressure, but what we learned from those 3 locations that had pressure was, wow, we're seeing some reductions in lodging. So in the moderate pressure here, the trait had 50% lodging, and TS201 as a standalone with nothing else had reduced that lodging. And then also in the high pressure, the insecticide had 53% lodging, and TS201 by itself was down to 29%, right? So we're moving the dial in multiple ways. And as Aaron said, I'm going to talk a little bit about that mode of action and what we know about the multiple modes of action. So we don't have it yet, but once data come in, this is what you will have to position it to growers next season. Is a bunch of large plot data. So we have 23 locations with the Intent Farmer Trials Network. And I know Newfields Ag and Yield Master Solutions together got a bunch of kits out. Maybe not all 40, but a sizable number, right? And we're expecting to get a lot of those back. Those are all kind of trusted trialing partners. So all of this, it will be available as a data package to support all the product positioning. So what we understand right now, right, again, it's a good complement to other management tools. It's going to have to be co-packed. We can't blend it in. Again, that's not an issue with moisture or anything else. That's just a regulatory issue. We're working towards being able to have it all blended in the single package, but that's not going to happen this season. And yeah, this really is a novel mode of action for insect biocontrol. So I'd love to share a case study. So fun fact, Newfields Ag did our very first customer trial with TS201 plus dust in 2022. Again, that was taking the grower standard practice and then comparing TS201 as a standalone to that. And then in 2023, we added the product positioning that we're looking at this season, which is, okay, well, what if we take the biostimulant and the biocontrol agent, put them together with dust, and then compare it to a real world condition of what the grower was already using. Of course, we would have loved for Gilbert to do, well, what if you stack them, right? What if you have the insecticide and this? Because that is how we're trying to position it. But this is how he wanted to look at it to really stress test it, right? But we, again, are not recommending it as a standalone. Go ahead, Roger.
Are you seeing slide 31 or are you seeing slide 26?
31.
I still see. So what does everybody else see slide wise?
I see 26.
I'm
Oh,
on
so I've been
26 also.
advancing slides this whole time and nobody told me they couldn't see them. I have an advancement on my side and it says live sync to presenter. Here. Oh, I have
Very
to
good.
But I'm the presenter, so.
what did we miss here? Anything good?
Just the large plot stuff and nothing
All
important.
right.
We're good.
Okay, we're good. Okay. Okay, sorry, still learning all the ins and outs of Teams. All right. Glad this is the internal presentation. Okay, so what we saw in 2022 when it was TS201 as a standalone with dust compared to a grower standard practice as an insecticide, we saw a reduction in lodging. And then that lodging was goosenecking. Nothing was fully laid over at that point, but we were measuring number and percent of goosenecking. And then the NIS scores were roughly equivalent, so a 1.3 and a 1.5. So it was a tiny bit higher, but pretty in line. Again, kind of amazing for a standalone. And then the yield also was roughly equivalent. So what the grower told us was like, absolutely, I see this as a win. I'm able to, on par with an insecticide, see some control. And we worked with an entomology consultant this season in 2022. Again, we didn't have like a fully untreated control, right, with no insecticide and no trait. But his estimation from looking at many of the roots and looking at the presence of adult beetles in the field, he said probably this field would have come in at a 2.5 on the 0 to 3 in terms of how much pressure the field overall received. So this was great to see in 2022, and then again.
I jumped in.
So am I advancing? Oh no.
You tell me when you go, I'll advance. How's that?
Okay, you go ahead. So then in 2023, the same grower had it in the same field, but again with the biostimulant, and we saw some great overall root changes, right? This was something that we saw in 2022, but we took some quick pictures and then, we're like, ooh, that was a lot of ratings, and we didn't really follow up, but it's something that we had seen. We had been jokingly calling it this beefy shoulders phenotype, because when you really crouch down, when you're photographing the washed roots, look at that difference in circumference of the whole root ball. It's really striking. Next slide. So we took them back to the lab. It was just 15 roots per treatment, but we did a nice grid and a good sample. So we took them all back to the lab to do some more in-depth image analysis and really take a look at, well, how is this changing the rooting system, and how do we think this might be adding to some of the benefits that we've seen? Why are there little yellow things on there? I don't even know what
I'm
that
doing
is.
that. That's me.
Oh, okay. Roger
I'm
would like me
highlighting.
to point out that there's, I thought I was losing my mind for a second there. Roger would like me to point out that there's some great additional nodes of roots. So the difference between grower standard practice and then the treatment was the entire 7th node of roots just wasn't present in grower standard practice. And that can help, in wind, withstandability, right? Those are the brace roots. And somehow our technology was convincing the plant to make more of them and have full other nodes actually occupied with roots. Go ahead, we're rapidly running out of time. So quickly here, looking at the full root system, we had better density in terms of how those roots fill the area, greater surface area, root length, root tips, and then this change in the steepness of the rooting angle. So steeper angle, which helps the plant actually not compete with its neighbors and access more nutrients in the deeper soil. And then that increase in fine roots as well, with which can help with nutrient uptake. Go ahead, one more. And then what really struck us here was this phenomenon of root regrowth after larval pruning. So after we photographed the crowns, we cut everything to pieces. We literally pruned every single root off to look at them individually. And what we found was where the larvae had actually pruned a root, which you can see in both of those cases, the pruning at the end, the plant will try to compensate and it'll try to regrow from right above the damaged site. And yeah, it did that a little bit in the grower standard practice, but it did it a lot with the Terrasym treatment. So we see this hyper aggressive regrowth that again can compensate for that damage and the structural issues that go with the damage and help the plant recover. So we think that's a lot of what's going on as well. So I think, go ahead, skip that one. Very quickly.
Talk about this. Michael. Yeah, you got time. Go ahead, Allison. Yes, please.
Yeah, so quickly here on the types of defense responses, and sorry, we probably should have asked for 90 minutes if we're doing the full product update and this. So sorry, we got behind there. Plants have their own immune systems, essentially, and there are 3 types of defense responses. The systemic acquired resistance, which is that red arrow. So that means if you have a pathogen attack, the plant can actually, that leaf can alert the rest of the plant to be ready for that same type of pathogen. And those are with signals that move throughout the plant and start the defense response in different areas of the plant. And then you have the herbivore-induced resistance. That's that blue arrow. So where you have an herbivore chewing on the plant, it causes damage. The signals travel throughout the plant, and the plant starts preparing itself, strengthening the cell wall, putting out all of its reactive oxygen species, like things that can damage the insects, and can protect itself. And then there's induced systemic resistance that does not require any damage at all to start. If you have beneficial microbes in the rhizosphere, they can just turn on the whole plant's defense system without any damage having occurred and can make the plant more resilient once damage does recur. That's those purple arrows coming up from the roots. So this is kind of how that plays out. If you don't have priming, so you don't really have those beneficial bacteria, you have an insect feeding event, the plant can mount a defense response, but it usually takes a while and it's a little bit smaller and can lead to a poor outcome for the plant. Whereas with the priming, you get that bump in defense responses without any herbivore damage or fungal damage or anything else happening. The plant just does like a boost. And then once you get the insect feeding, you get an earlier and more intense defense response that can actually lead to a better outcome for the plant. And I love when I first showed this cartoon to Aaron, he's like, oh, it's like a vaccine, right? Yeah, it's like a plant vaccine. You can tell it like, hey, be careful, watch out, like, start to get your own defenses going before the challenge actually comes around. Yeah, and then just a bunch of pretty pictures from here, but maybe one more. Yeah, so this is really where we're thinking and we're working with multiple partners to untangle these modes of action. And that will be more data that will be available for product positioning as well. So we have that root regrowth stuff. This may increase root regrowth. Now that we have that case study, I'm going to change that to, yeah, it increases root growth. I believe it. I've seen it myself, right? So yeah, thanks so much, Aaron. And we're working with different partners to look at feeding response studies in terms of choice experiments with the larvae. And then we're looking more into the plant defense response as well. So come kind of January, February, we should have a much more fleshed out understanding of that mode of action, and then kind of fully digested in some great marketing assets to help tell the story of the product. So
Allison, can we
the goal.
share who these partners are? They're not distribution partners. They are research partners.
Oh yeah, sorry, research partners. Yeah.
Yeah.
Universities and USDA and yeah, lots of great folks. So cool.